Ever wanted to tap into your powerful home PC when you're on the road, but, without leaving it running 24/7, just burning electricity and cash? Well, there's this awesome tech called Wake-on-LAN that lets you do exactly that. But, and this is a big but, trying to do this from anywhere on the internet opens up a huge security can of worms. So let's dive in and figure out how to do this the smart way, and way more importantly, the safe way.
First things first, let's talk about why we're even doing this. You've got that beefy desktop at home, right? Maybe it's for gaming, maybe it's a media server. When you're not using it, it's just sitting there, idle. But here's the thing, idle doesn't mean free. Oh no, it's sipping power constantly. And that cost, well, it adds up way faster than you'd think.
I mean, the difference is just staggering. Have a look at this. A high-end PC just idling, doing nothing, can easily cost you over $100 a year. But put that same PC to sleep or turn it off, that cost plummets to maybe $5. That's a 95% saving. That's real money we're going to put right back in your pocket.
So how do we get those savings without giving up the convenience of having our machine ready when we need it? Well, it all comes down to this really clever bit of networking tech, something they call a magic packet.
Wake-on-LAN, or WL for short, isn't some weird hack. It's a built-in industry standard. It's a feature that lets your computer, even when it seems totally off, keep just a tiny bit of its network hardware listening for a very specific message that tells it to spring back to life. It's basically a remote power-on switch. So how does this magic actually work? It's really just a simple four-step dance. First, your PC's network card chills out in a super low power mode, just listening. Second, some other device on your network sends out the packet. Third, and this is the secret sauce, that packet has a unique payload, kind of like a secret handshake. It's got the unique hardware ID of your network card, its MAC address, repeated 16 times. And when your network card sees that specific pattern, it's the only one that recognizes it. It knows that message is for it, and it tells the motherboard, hey, time to wake up. It is literally a remote power button. Okay, so as cool as this sounds, let's be real, it's not always a simple one-click setup. Most people who try this get tripped up in one of two places, either deep in the hardware settings of the BIOS or with a really annoying software setting in the operating system itself. So first, the hardware. You gotta reboot and jump into your PC's BIOS settings. The first bit is obvious. You have to find a setting called Wake-on-LAN or something similar and turn it on. But here's the part that gets everybody. You also have to disable some other power-saving features. Look for stuff called Deep Sleep or ERP. They're designed to save that last tiny watt of power, but they do it by completely cutting power to your network card, which totally breaks Wake-on-LAN. The absolute dead giveaway test, shut down your PC. If that little orange or green light on your Ethernet port is still blinking, you're golden. Now for the software side. Even if you get the hardware settings perfect, your own operating system can stab you in the back. See, a lot of them, by default, will tell the network card to power down completely when you shut down, basically giving it amnesia. It forgets all about your Wake-on-LAN setting. The key here is to make that setting persistent, telling the OS to leave that network card listening no matter what. You have to make that setting stick so it survives a reboot. Okay, so you've done all that. You've got it working on your local network. Awesome. Now you want to wake it up from across the internet. This is the moment where so many people take a shortcut that is just incredibly, incredibly dangerous. Just look at this comparison. On the left, you've got port forwarding. This is like punching a hole straight through your router, opening a door directly from the Wild West of the internet into your private home network. On the right, you have a VPN. This creates a secure, encrypted tunnel. You connect to your network first, and then, once you're safely inside, you send the wake-up call. This analogy from the source material absolutely nails it, so I'm going to say it again. Using port forwarding for Wake-on-LAN is like leaving your front door unlocked and wide open to a busy street. You'd never do that with your actual house, so why on earth would you do it with your digital one? But here's the kicker. This is the really fascinating part. Even if you were willing to take that giant security risk, the port forwarding method usually just stops working after a few minutes anyway. So what's going on there? All right, let's follow the journey of this poor, doomed magic packet. It travels all the way across the internet, it gets to your router, and your port forwarding rule sees it. It knows, okay, this is supposed to go to your PC's IP address. So far, so good, right? Well, here's the problem. To actually deliver that packet on your local network, the router needs the PC's physical MAC address. It needs to know where to send it. So it checks its short-term memory, and if it's not there, the router basically yells out to every device, hey, who has this IP address? I need your MAC address.
And what does the router hear back? Crickets. absolute silence. Your PC is off. It's not running an operating system. Its network stack is asleep. It is completely incapable of answering the router's question.
So with no answer, the router has no clue where to physically send the packet. It's got an address, but no destination. So it just throws up its hands, discards the packet, and moves on. Your PC never gets the message. And that's the punchline. Port forwarding isn't just a massive security risk. For this job, it's fundamentally broken.
So if that's the wrong way, the dangerous and broken way, what's the right way? Let's walk through how to do this securely and reliably, the way the pros do it. This table really breaks it down perfectly. Port forwarding, extreme risk. Don't do it. A proper VPN, that's a fantastic low-risk solution. You connect securely to your home network first, and from that point on, you're basically local and can send the packet safely. But the absolute gold standard for security down at the bottom is using a modern mesh VPN like Tailscale with what's called a jump box. That's just a fancy term for a tiny, low-power, always-on device like a Raspberry Pi. You securely connect to the Pi, and then the Pi sends the wake-up call to your big computer. With this setup, you have zero, and I mean zero, open ports on your router. Your home network is effectively invisible to the outside world.
Okay, we've gone through BIOS settings, network protocols, the whole shebang. But if there is only one thing you take away from all this, I want it to be this.
Here it is, the big one. Convenience should never, ever compromise security. The secure methods, like using a VPN or a jump box, give you that exact same power-on-demand convenience you wanted, but they do it without leaving your digital front door wide open for anyone to walk through. And I just want to leave you with this one last thought. You probably back up your important files, right? Of course you do. That's smart. But have you thought about your network security in that same way? Your files might be backed up, but is your network's front door locked?